Question number 2. Look at a reservoir in the shape of an inverted cone, and the cross section is an equilateral triangle. So I know an equilateral triangle would be all sides the same. So I'll try my best to draw an equilateral triangle. And it mentions the water being pumped out of this reservoir. And again, this is supposed to be a 3D shape, and I have drawn just the cross section as if I've cut down through it. And it mentions that the water is being pumped out of the reservoir at 2 meters cubed per second. And we've got the height of the water when the height is 40. So because it talks about water dripping out of this reservoir, I know I'm thinking about volume. So I want to think about what would be needed in a volume. It also mentioned height. So I can go ahead and label that. Knowing I need volume, volume actually involves the radius and the height. So I'll figure out, well, there's the radius. Starting here, going from here to here is the radius. So this side would be, because this is an equilateral triangle, this side is 2r. So I know I need 1/3 pi r squared h is the volume of a cone. And I'll need to think about a way to get that. And I know we've practiced already getting the differentiation of that particular function, but wouldn't it be easier if we could get it into one variable? So one of the things I want to think about is there a way to write any of the equations that I use in terms of one variable instead of two? So I'm going to look up here to think, well, I've got a right triangle here. What if I think about that as being 2r squared equals h squared plus r squared? Thinking about Pythagorean theorem and calculating this out, well, that would be 4r squared, h squared plus r squared. Subtract 3r squared equals h squared. And r squared would be 1/3 h squared. And the reason I solved for r squared is because I already have that over here. It would be easy to substitute 1/3 h squared in the place of this r squared. So let's rewrite this. Volume, it's 1/3 pi. Instead of r squared, I'm going to put my 1/3 h squared and then times h. If I simplify that a little bit more, and again, I don't have to simplify, but the reason I want to is because I've got to take the derivative and it will make it easier. 1/9 pi h cubed is the volume of this cone in terms of h. Let's do the derivative of that, dv dt equals 1/9 pi times 3h squared. We took the derivative of h, so we'll do dh dt. And that simplifies down to pi over 3. When the 3 and the 9 simplify, h squared dh dt. Of course, we need to organize the information. What am I going to be trying to find? What am I given? What kind of information do I have? So we know the height of the water is 40. So we have that information. And we know that the water is being pumped out of the reservoir at 2 meters cubed per second. So let's see what other information I can get to. The volume of the reservoir is dV dt. It's being pumped out, so it's 2 meters cubed per second. And we were told the height is 40 seconds. Not 40 seconds. 40 meters. And I need to find, let's go back and see that again. What is it I need to find? At what rate is the height changing? So I'm being asked to find dH dt. So do I have everything I need? As I look back at the equation that I have a dV that I'll be looking to find, or I've given, so I have a dV answer. I have h, and I need dH dt. So it looks like I don't need to solve for additional variable this time. Since we used the relationship between R and H early on, I don't have to find any information. So there's nothing I need for step 5. So I can skip that step and move on to step 6. So I need dV dt equals pi over 3 h squared dH dt. And let's put in the part we know. This is -2. This is 40 squared. And I'm trying to find dH dt. So if I were trying to do that without a calculator, then let's see how I could do that. That would be dH dt. I could multiply the 3 times the 2, so I'd have -2 times 3. And I could divide that by 40 squared and pi. And that would be a perfectly valid answer for a no calculator part of the test. But if it's a calculator question, you could certainly go ahead and get an answer for that. 0.00119 meters per second. So the height of the water is dropping, because it's negative, at a rate of 0.00119 meters per second when the height is 40. So that's what we know to be true that I could find for the value of this question that it's asking me to find the rate of that height.